All right, boys and girls, so you solved all sorts of equations last chapter, and now we're going to switch up and move on to something quite a bit different. We're going to take a break from solving equations for a little bit, and we're going to move on. And what we're going to start with today is something called prime factorization. Prime factorization. So what does that mean? Well, every composite number, so there's numbers that are prime and numbers that are composite. So a prime number can only be divisible by 1 and itself. That's it. So prime numbers are 2, because it only can be written as 2 times 1. 3, 3 times 1. Nothing else goes into 3. Then you have a composite number. Composite numbers are numbers that can be multiplied by something else. So 2 and 3 are prime. 4 is a composite number because it's made up of 2 times 2. All right, 5. 5 is a prime number. 6. 6 could be 2 times 3, so that's composite. 7. 7 times 1. 2 doesn't go into it. 3 doesn't go into it. 4 doesn't. So 7 is a prime number. 8, composite. All even numbers except 2 are going to be composite because 2 can always go into those numbers. So 8, 9 is 3 times 3. 10, get to 11. Only thing that goes into 11 is 11 and 1. So, and we could do this list for on and on and on and on and on. The important numbers to remember, the composite, are the prime numbers. Lots of composite numbers. Prime numbers get pretty rare as you get higher and higher and higher. 13 is prime. 15, no, 5 goes into it. 17, 19, 21, nope, 3 goes into it. 25, 5 goes into it. 27, 3 goes into it. So they start to get more and more rare. 29, 31, and this list goes on and on and on. We could keep going. But it's important to note, for every composite number, you could write it as the product of 2 primes. Every composite number can be written as the product of 2 primes. You can break a number down. 4 is 2 times 2. 6 is 2 times 3. 8 is 2 times 4. 9 is 3 times 3. 10 is 2 times 5. I take these numbers and multiply them together to make composite numbers. All right? So, what we're going to do is we're going to spend a lot of time doing a prime factors. We're going to find the prime factors of a number, and the way we do that is a factor tree. You may have seen these before. Okay, so how do you find the prime numbers? 35. What goes into 35? Now, you may not know off the top of your head, but you have a calculator there. You can guess and check. But there's some numbers that you should be able to guess pretty quickly. Like, for example, anything that ends in 5, you know, or you should know, 5 goes into all of those numbers. So I just need to think, or I grab a calculator. 35 divided by 5 is 7. So 35 is 5 times 7. So when you do this on a factor tree, then you check to see if you get a prime number, your branch is done. So 5, we had that list earlier. 5 is a prime number. 7 is a prime number. So we're done here. That's it. So 35 is 5 times 7. You get to a bigger number like 210. So, bigger number. Lots of things probably go into this number. But again, if you're smart about where you start, 210, anything that ends in 0, I know 10 goes into that number. So if I prime factor this, I would do 21 times 10. Okay, 21. Is 21 a prime number? No. 7 times 3. So then I break this down as 7 times 3. Is 10 a prime number? Or is there something that will go into 10? It's an even. So 2 times 5. There's 7 prime, 3 prime, 2, 5, all prime. So 210, and when we write this out, we usually write them in order, is 2 times 3 times 5 times 7. This is the prime factorization of a number. If you're not catching this right away, we're going to spend a couple of days on this topic, okay? Don't rush through it. But that's where we are. Any questions on that? Let me know. So, you can write prime factorization in standard form and exponential form. Standard form and exponential form. Standard form means you write them all out like this. Exponential form means you write them with exponents. So, how many 2's are there in this list? 1, 2, 3, 2. So we would write 2 to the third power. How many 3's are in this list? 2. So I have 3 to the second power. How many 7's? 1, 7 to the first power. Okay. Example 2. Again, we like to go in order. How many 3's are there? Or 2's, excuse me. How many 2's are there? 3 of them. How many 5's? 4. And how many 11's? 1. Example 3, is that a prime number? No, it's not. Okay, so 15 would break down to 3 and 5. So I've got a 2, a 7, a 3, and a 5. So there's 1 of each. 1 of each. So this is standard form where they're all multiplied and you write out all the factors. This is exponential form. And there's sometimes when we'll use both of them. So you need to understand how to write an answer in both. Okay? So we have standard form and exponential form. There we go. So, next example, and again, make sure you're writing these in your notes. It's write the prime factorization of each number in standard form and exponential form. So here we go. 48. How do I get started? What goes into 48? Well, when you're sitting at home, hopefully you recognize that's an even number. So look here, 8's an even number, so I can start with 2. So when I get out of my calculator, 48 divided by 2, 24. 2 is a prime number. I'm done with the 2 side of the branch. Now I need to break down 24. If you can think of bigger numbers, it'll go faster. If you can't, you can just keep dividing by 2 until you get to some numbers that you can recognize. So 24, again, I know it's even, so I can go with 2 and 12. Done with that branch, 12. 2 and 6. 2 and 3. So 1, 2, 3, 4 2's and a 3. This is standard form. And now we need to write the same answer in exponential form. How many 2's are there? How many 3's? Same answer. I didn't do any extra work. Standard form, exponential form. I do want to show you something else here. There's lots of ways to get this answer. So, let's say you know 48 is 6 times 8. 6 times 8. 6 is 2 times 3. 8 is 2 times 4, 2, 2. So like I said, if you can think of bigger numbers right off the bat, there's less work to get done. But you get the same answer. Here's 1, 2, 3, 4 2's and 3. 1, 2, 3, 4 2s and a 3. Notice when I'm writing my standard form answer, I don't use these numbers. You only use the numbers at the end of the branches. Those are our prime numbers. And if those numbers are not prime, then you keep breaking it down until you get to prime numbers. I wrote that prime number list in the beginning. You're going to want to have that handy as you're going through these problems. All right, let's do another one. Whew. That's a big number. You have calculators? What goes into 9,000? Well, anything that ends in 0, we would start with 10. If it's 9,000, we could start with 1,000. But let's start with 10. Again, get out the calculator. 9,000 divided by 10, 900. Keep breaking it down. This is not prime, this is not prime. Keep going. 10. 2 times 5. Is 2 prime? Yes, it is. It's on that list from the beginning. 5? Yes, it is. It's on that list from the beginning. Okay, go over here to this branch. 900. Again, ends in 0, so I've got 10 and 90. 10, well, we just did that. That's 2 and 5. 90, 9 and 10. 9, not prime. Keep going. 3 and 3, 2 and 5. Holy cow, I've got 1. So let's just look at our numbers here. I've got a 2, a 5, a 2, a 5, a 3, a 3, a 2, a 5. Remember, only use the numbers at the end of the branches. So I've got 3 2s, 2 3s, and 3 5s. There's my standard form. Exponential form. There's 3 of those. There's 2 of those. Make a mess here. And there's 3 of those. That's where I'm going to leave you today. Prime factorization, standard form, exponential form. We're going to spend about 3 days on this. So you're going to get plenty of practice, and then we're going to use this for all the stuff that we're doing the rest of this triad. So you need to make sure you understand these first couple of lessons here. Reach out if you're having problems. If not, get your assignments done. See ya.